In this video, we're going to go over a quick little review about how to write equations from stories or tables. Now, before we go into this, I want to talk about a couple definitions. The first of which is rate of change, or the amount a dependent variable changes, and coefficient, the number being multiplied by a variable. And actually, you should know as you're copying these two definitions down, these two are the same thing. Rate of change and coefficient are the same thing when you put them into an equation. So let's use an equation that we're familiar with. If you remember from yesterday and from the day before that, we were talking about raising money for different charitable events. And we know that one of the runners, Gil, what he did is he was allowed to run in a race, and his sponsors told him he would make $2 every kilometer. Now, when we came up with our equation, everyone came up with the idea that it was 2 times the number of kilometers would equal the number of donations. So right here, the rate of change, the amount a dependent variable changes. So if you remember, I'm going to put my table over here so we can remember what was exactly happening. So on this side we have kilometers, on the right side we have the number of donations. 2, 3, 4, let's just do it up to 4 kilometers. And what we have is the rate of change changing by 2 each time. So every time that the number of kilometers changes by 1, the donations are going to change by 2. So our rate of change is 2. So 2 times 0 is 0, times 1 is 2, times 2 is 4, times 3 is 6, times 4 is 8. So right here, these are our rates of change. See, it's changing by plus 2 each time, only when we go up by plus 1 kilometer on our left side. And again, our coefficient is the number being multiplied by the variable. Well, 2 is being multiplied by our variable over here. So again, in this case, the rate of change and the coefficient are the same thing. So make sure that you get all of these notes into your notebook right now. Now next, I want to talk about two ways you can write an equation. One is where the rate of change is already given to you, and the other is where the rate of change is not given to you, and you have to find that first. So in this case, we have that April made $15 an hour. Write an equation comparing her pay P to the number of hours she works H. So we already have our rate of change, or you could also call it the unit rate. We know that she makes $15 an hour, so I'm just going to write a random example. So she makes 15 bucks an hour, and I know if she works 2 hours, that's going to equal $30 because 15 times 2 equals 30. And I can replace these two values with variables because I need to represent the variable P for her pay and H for the hours. 15 is my rate of change, or my coefficient, so that's not going to change. 2 is the number of hours that she's worked, so I'm going to put H. And 30 is the amount of pay she earned, so that's P. So our equation would be 15H equals P. Our rate of change is 15, and our coefficient is also 15. In this story, we have that May made $55 in 11 hours. So we don't know the unit rate, we don't know the rate of change here. All we know is that she made $55 in 11 hours. So this is where we might need to use a proportion in order to figure out exactly how much money that they're making. So here, after 11 hours, we divide 55 by 11, and we see that they're only making $5, so I'm going to use M for money. Actually, I should probably use the dollar sign in this case, just for our proportion. Definitely not in our equation. So $5 every 1 hour. So I can tell my rate of change is $5 every 1 hour. And again, I'll use the 2 for an example. If she works 2 hours, that's only $10, so 5 times 2 equals 10. I know 5 is my rate of change. I'll keep that. 2 represents the number of hours, and 10 represents the amount of pay. So right here, pretty easily, using proportions and not using proportions, I've come up with my two equations. The one thing that you definitely want to remember is that if you have your unit rate, you can just go ahead and come up with an example and come up with your equation. Here, our unit rate isn't so strictly given, so we had to come up with our own unit rate, which is why It took us a little bit longer to come up with an equation for this example. Next, I want to talk about finding an equation based on a table. So right here, we're comparing the number of chips we can buy to the amount of money we spend. So of course, if we're not buying any chips, we don't have to spend any money. But when we buy one bag of chips, that's $3, so that's plus 3. We buy another bag of chips after 2 bags of chips, that's $6. So we're still coming up with a rate of change of 3 because this is changing by 3 each time. If I wanted to come up with an equation for this, I know that for a bag of chips, so however many chips we buy, we have to multiply that by 3 to get the amount of money. So my rate of change is going to be 3. We multiply that by the number of bags of chips that we get in this example, and that will give us the amount of money that we're spending. And we can come up with a random example just to make sure this makes sense. So 3 times 2 is going to give me 6. 2 represents the number of chips we buy, and 6 represents the amount of money that we've spent. Now, I want to talk about something that a couple people had difficulties with yesterday, and that was the graphing portion of the equations, of the tables from yesterday. So in this example, we're still using the same table, and we can still see that our rate of change is plus 3 each time. And again, last time our equation was 3c equals m. So we're going to say that the amount of money that we're spending is our y-axis. So the higher our graph goes, we know that's the more money that we're spending. And this y-axis is the amount of chips that we're buying. So the farther along we are on this part of our graph from left to right, that means the more money we're spending on chips. So I know if I spend if I purchase 0 chips, that's $0. So I want to go right here at the origin. So 0 chips, $0. If I buy 1 bag of chips, that's $3. So I go to 1 bag of chips and I go up until I reach $3 over here. 2 bags of chips, that's $6. So I'm going to go all the way to 2 and jump all the way up here to represent $6. And then again for 3, I want to go to 3 bags of chips and go up to $9 right over here. And just for double checking, we're going to go up to 4 bags of chips, and that's $12 according to our table because we add by 3 each time. Our rate of change is 3. And if we've done this correctly, we should get a straight line, pretty straight, going through all of these points. So right now we have our graph that represents our table, and we also use this equation to help us out too. So we're going to get a little bit more practice with this. So here we can see that we have kind of an interesting graph because at 0 miles, this person's already raised $6. So we're going to, in order to create our equation, first we need to find our rate of change. So we go from 6 to 11, which means plus 5, and from 11 to 16, that's plus 5, and from 16 to 21, that's plus 5 again. And you can see that our rate of change is plus 5. So I know that our rate of change is 5, and that's important to remember because this is going to be our coefficient. Now we started out with $6 in donations, which means that we've added $6 to our original amount. So our rate of change in this example is 5. We multiply that by the number of miles we go. This is our independent variable. And then we're going to add 6 because we know that no matter how many miles we run, or I shouldn't say that, but if we run 0 miles, we'll still have $6. So I need to make sure I add that on to the rest of my equation. And that's equal to the amount of donations. Now here, you're going to see that we're not going to start at 0 like we did last time. Actually, we're going to start at 6. So right here, we're going to say these are the number of miles we complete. And over here are our donations. I'm just going to use a dollar sign for donations up here. So after after 0 miles, we've still raised $6. After 1 mile, we've raised $11. 2 miles, I'm going to go up to $16. 3 miles, that's $21. 4 miles, that's $26, which is way up here. Now, if I've done this correctly, there's going to be a straight line going through all of these points. And it looks like we've done this correctly. Our rate of change is the same. I can kind of see that we're still increasing by 5 each time. We have a straight line. So I can tell that this is a linear equation because I have a rate of change that stays constant. Over here I can see that this is plus 5, plus 5, plus 5 in our table. And then we can tell that this is linear because we do have a straight line here. All right, if you have any questions on the assignment, please feel free to email me and I will reach you as soon as I can. Don't forget, the tutoring days for next week are Monday, Tuesday, and Wednesday. There is going to be no tutoring on Thursday. If you have any questions, feel free to email me.